Hey, Math 10, welcome. We're going to be doing lesson 1-1 today. It's going to be about number systems, which are basically categories of numbers. We're going to be using these categories all year, so it's going to be important to know what these words mean so that when we encounter them later on, you know what I'm talking about. So these are very common categories. You may have even heard of them or seen them before. So this might be a bit of a review. So the first category we're going to talk about are the natural numbers. You could think of these as counting numbers. You know, if something was in nature and you wanted to count how many trees, how many stones, I don't know. These are sort of the counting numbers. So 1, 2, 3, and so on. That's our first category. And we're going to go on to sort of the next category, but it's not just about sort of like these categories and what their names are, but also how they relate to each other. So the next category is going to be what's called the whole numbers. And the whole numbers will contain all of the natural numbers, in addition to adding a new number. So these are the whole numbers here. So what the whole numbers do is they, including the natural numbers, they also add in the number 0. Maybe I'll just write it as a 0 right here. Boom. The number 0 is sort of part of the whole numbers. This is a bit of a weird one. I always kind of wondered, like, what's the big deal? Why do they even have natural numbers? Why don't we just talk about whole numbers? Whole numbers include 0 and all the natural numbers. Natural numbers, they don't have 0. That's the only real difference there. It's okay. Whatever, I don't mind that. I'm not too worried about that. The next category of numbers does have a significant improvement, or not improvement, but an additional sort of grouping. So I'm going to draw this next sort of category further out. And this one is going to be called the integers. Integers. So, so the integers, in addition to all the whole numbers, they also include negative natural numbers. So, -3, -2, -1, and further on down the number line. So integers are, all those sort of counting numbers, n0 and the negative counting numbers. So yay, integers. Integers do not include things like decimal numbers or fractions. I guess technically you can write 3 as a fraction or something, but not fractions that don't work out to be integers. So, okay, that's kind of obvious. The next category is going to include those fractions, though. So the next category are called rational numbers. So we're going to go out to, what comes after this in the rainbow? I think it's green. Not too sure. Apparently I don't know my rainbow. That's okay. I think I did good. Boom, here we go. So the deal with the rational numbers, let me just type that up here. Rational numbers are all these other numbers too, right? They're the integers, whole numbers, and natural numbers. They include all those things, but they also include fractions. So anything where you could write it as a fraction, like, some kind of number, like I'm using the letter P to represent one integer over Q. So a fraction, this could be 2 over 3. It could be 9 over a million. It could be, 1 over 2, 1/2. The rational numbers include fractions as well as all the other numbers that are sort of contained inside. So there you go. This is a kind of a stacking sort of category system, which is great. And then over on the side here that's not related, or at least not like directly connected, are what are called the irrational numbers. It's a sort of a separate category that's all on its own over here. They're not really related to the other numbers. Irrational numbers. Irrational coming from sort of the idea that they don't make sense. In the ancient times, people really struggled with understanding these numbers. So they're their own category, all on their own here. We'll put them in blue. So irrational numbers include any of those numbers that go on, like a decimal number that goes on forever and never repeats. One of the most perplexing of these irrational numbers in human history is the number pi. Pi is that number with circles, usually involves circles, right? Technically, pi is the number of times you can take a diameter and wrap it around the circumference of its circle. So that number never repeats and it goes on forever, which is kind of crazy. You can also get that with square roots of numbers that aren't perfect squares. So for example, the square root of 3 produces an irrational number. Not all square roots are irrational numbers though. For example, the square root of a perfect square, like the square root of 4, is actually a natural number, which also makes it a whole number, an integer, and a rational number as well. Because the square root of 4 is just 2, so that's not irrational. So you got to watch out for those things. So now we have these categories of numbers. Guess what? All these number systems together have a name. So including, oops, I can't seem to select these like colors. I'm not even going to try. I just have to like edit this. Boom, the whole thing. Dun, da, da, da. Wow. These all combined are called the real numbers. The real numbers. So every number in here, irrationals, whole numbers, integers, rational numbers, they are all real numbers. These are all the numbers that can be represented on a number line. They're all in there. Every single one of these numbers are on a number line. Now, this isn't really Math 10, but I just wanted to mention that in addition to the real numbers, there are actually other numbers that don't exist on the number line. And that's like a pretty weird thought to have. And there's a special name for these numbers. Usually they're called complex numbers or imaginary numbers. So in addition to real numbers, we also have imaginary or complex numbers. I think the term complex numbers is the preferred term. You won't actually see these in Math 10, so don't worry too much about these. What the heck are complex numbers? So for example, I don't even know what color to use. We got like this rainbow color, maybe? We'll use the rainbow color. Oh, that's not rainbow. Hey, why you not give me rainbow? I asked for rainbow. Let's see, am I in rainbow? Yeah, now we're here. Complex numbers. So complex numbers are things like the square root of -1. If you think about, we haven't really talked about square roots. We're going to talk about them soon. Think about the square root of -1. There's not really an answer, right? The square root of 4 is 2 because 2 times 2 is 4. So what number times itself gives you -1? So -1 times -1 gives you 1. And 1 times 1 gives you 1. I can't use -1 times 1 because it has to be the same number times itself. So there's not really a number, is there? There's no number. Turns out there is a number. They're complex numbers. And this was a very difficult math problem that people were trying to figure out when they invented electricity. When people, mostly they were in Scotland, oddly enough, Scottish scientists were trying to figure out what the heck is about how do we capture electricity and harness it for doing things like, having lights and things like that. They were trying to understand how the equations, the math of electricity works, and they always kept getting to this square root of -1. And they thought they had made an error. They thought they actually had made a mistake. And they kept on trying over and over and over again to figure out what's the answer. And the answer kept on coming out to the square root of a negative number. Eventually, they just decided, what if that's actually the answer? What if the answer involving all this electricity stuff turns out to be a number that's actually not on the number line? And that was like a huge breakthrough. So there's this whole other set of numbers that people started discovering in sort of the late 1800s as they were investigating science and electricity and stuff that helped them to discover other numbers exist out there. So it's kind of cool that there are number systems. You know what? I'm just going to scroll back here. Whoa, not too far. I'm going to scroll back here. These are the numbers we really need to worry about, though, for Math 10. These are the kinds of numbers we're going to look at. And I'm going to show you in a moment about just like the kind of questions you're going to get and how you can deal with those questions. Okay, thanks so much, Math 10. We'll talk to you in a second in another video. Bye.